All right, so welcome back. We are carrying on with lecture one. So this lecture one focuses on conditionals, if statements, control flow, elif and else or, and modulo, creating an parity function, Pythonic, match, and summing up. So conditionals allow you, the programmer, to allow your program to make decisions, as if your program has a choice between taking the left-hand road or the right-hand road, based upon certain conditions. Conditionals allow your program to make decisions, choosing one path over another, depending on specific conditions. Built within Python are a set of operators that are used to ask mathematical questions. Less than or so greater than and equal symbols are probably quite familiar to you. Greater than equal denotes greater than equal to. Less than equal to denotes less than equal to. Equals equals denotes equals. Note the double equal sign note the double equal sign. A single equal sign assigns a value, whereas two equal sign compares values. Exclamation mark equals denotes not equal to. Conditional statements compare a left-hand term to a right-hand term. If statements. In a terminal, a window type code compare.py. So let's create a new file. This will create a brand new file called compare, and the text editor window, we can begin with the following. So let's create a new file, call it the Python file, call it compare.py. And let's say x equals int input what is y, and then this is actually doing this wrong place. I want to put it in my compare file. There we go. This is the one I want. So there you go. And we can just copy that because it's pretty much the same code. What is x? Fix that. It's x. And what is y? And then if x, this is how you create if statements. Start with the keyword x, less than y. Then print x is less than y. That's it. That's our simple if statement. We have an if statement and we're comparing two variables together. This will give an output either true or false. If it's true, it does this. If false, it will do nothing. It will continue with the program. So now notice how your program takes the input of the user for both x and y, casting them as integers and saving them into their respective x and y variables. Then the if statement compares x and y. If the condition x is less than y is met, the print statement is true and is executed. If statements use Boolean values which are true or false to decide whether or not to execute the code. If the comparison x is bigger than y is true, that the interpreter runs the indented block. This is the indented block, very important with conditional statements and flows. This is indented. So let's run this code. Let's click on run compare. Run compare. Say 5, say 3. Mistake here. This is my mistake. I'm saving this both as y, so it's complaining there. It's a good example. For error, a bug in the code, y is not defined, which was true. I did not define y, now it is defined. Let's run it again. What is x? Say 5 and it's 3. It does nothing because x is not less than y. I chose x is equal to 5 and y is equal to 3. So it is not less, 5 is not less than 3, so this doesn't happen. But if I run it again and say x is 3 and then 5, it'll say x is less than y, which is correct. Control flow, elif and else. Further revise the code as follows. Now we're going to add more code. I'm going to just copy and paste this just to save some time, but it's good for you to practice and type it out as well if you want. So I'm going to paste this right here. So we add more conditions, more if statements. Now we're checking x is greater than y and x is equal to y. So let's run this code again. Notice how you're providing a series of if statements. First, if the if is statement is evaluated, and the second if statement runs its evaluation. Finally, the last if runs its own evaluation. This flow of decisions is called control flow, and this is how your code is defined in a coding diagram, a block diagram. Start our code, we check x and less than y. If it's true, we print the statement x is less than y. If it's false, it goes to the next statement, checks is x bigger than y. If true, print the statement. If it's false, then it goes to the next condition. Is x equal to y? True, x equal to y. False, it just stops. So let us first run this code before we improve it. We can save this and we start with our usual 3 and 5. X is less than y, which is fine. Let's do 5 and 3. X is greater than y, which is correct. One more time, 5 and 5. X is equal to y. So our code is working pretty well. This program can be improved by not asking 3 consecutive questions. After all, not all 3 questions can have an outcome of true. Revise the program as follows. Now, instead of putting multiple if statements, we put elif, which stands for else if. Let's see what that does. See how that changes our code. Notice how the use of elif allows the program to make fewer decisions. First, the if statement is evaluated. If this is found to be true, all elif statements will not run at all. It exits the code. The previous code, it did check each condition. However, if the if statement is evaluated and found to be false, the first elif will be evaluated. If this is true, it will not run the final evaluation. This is how it works. Code diagram. Start by x is less than y. If it's true, it runs a statement and exits the program, right? Look at the difference here. If x is less than y and true, it didn't exit the program, it checked for the next statement. So again, if x is less than true, if it's true, it prints a statement, x is less than y and exits this if statement, right? Which is a bit better programming process. If it's false, if x is bigger than y, if this is true, then it runs x greater than y and exits the if statement. If it's false, it checks x is equal to y. If that's true, prints a statement and then exits, else it's false. So while your computer may not notice a difference of speed-wise between our first program and revised program, consider how an online server running billions of trillions of these types of calculations each day could definitely be impacted by such a small coding decision. There's one final improvement we can make to make our program better. Notice how logically elif x equal to y is not necessary evaluation to run at all. After all, if logically x is not less than y and x is not greater than y, x must be equal to y, which is true. Therefore, we don't have to run elif x equals y. We can just create a catch-all statement. Default outcome using else statement. We can revise it and just say elif. So just one more time. If x is y and y is 3, this is not true. It goes to elif. Well, let's say it was true. Let's say it's 3 and 5. Then if this is true, it prints a statement and exits the program. In the previous code was just elif. When we had this, if this was true, it wouldn't exit the program. It will go to this condition and check it. And then if this is true or not, if this is true to print it, and then it would do this condition. So it checks each condition irrelevant of if it's true or not, which is inefficient. Right? So the last improvement is just to change this to else, because this is a catch-all statement. If it's not less than equal to y, not less than y or greater than y, it must be equals to. So this is a bit more efficient. Notice how the relative complexity of this program has decreased through our revision. Our code can be represented as follows. can see our diagram is far less now. We have a catch-all situation. If it's false, it just must be equal to y. Or the or statement. So the or statement allows your program to decide between one or more alternatives. For example, you could further edit our program as follows. Notice that the result of a program is the same, but the complexity is decreased even more. The efficiency of a code is increased. We can check if x is less than y or x is bigger than y, means x is not equal to y, else it is equal to y. Right? So quite simply, it does take away some more information. It doesn't tell you if it's bigger than or equal to y. So that's one, we're actually losing information. But depending on what you want, that's also an option. At this point, our code is pretty great. However, we could the design be further improved? We could edit it further on by replacing it with saying one statement which simplifies it even more by just saying if x not equal to y, print x is not equal to y, else print x is equal to y. So this is just efficiency's sake, understanding these, making more efficient. But if you understand the code, if this makes more sense to you, then rather use this because it keeps all the information we need. And trying to make your code more efficient sometimes makes it a bit more complex to understand for yourself. So if this is better, stick to this one. For the purpose of, okay, we are here. Notice how we remove the or statement and simply ask x is not equal to y. Just one question is very efficient. For the purpose of illustration, we could also change our code as follows by using double equals instead of not equal to in the same way. Notice that the equal operator evaluates if what is on the left and right are equal to one another. The use of double equal sign is very important. If you use only one equal, an error will likely be thrown by the interpreter. Now, our code diagram is far more simpler, but again, you're kind of losing some information, so I would recommend just sticking to this one. It's also very quite verbose, explains exactly what you need, and keeps information. The AND statement. So similar to OR and AND can be used with conditional statements. Execute the following code. So let's create a new file called grade.py. Let's open that up. And let's copy and paste this code here. See how it works. So we are expecting a score from the terminal, and we're checking if the score is bigger than or equal to 90 and less than 100, give it an A. If this is false, then check this condition. If it's bigger than 80, less than 90, then give it a B. If this is false, then do 70 and 80, grade C. If that is false, then do 60 and 70, grade D. Else, the default grade is F. So, this is a useful check looking at the AND statement. The AND statement allows us to check two conditions. So let's give it a try. We can run it. We can run the code and see what we get. If we say now that if we go back to lecture 1, and if we say let me just close this away so we can see it. If we can see % run and grade, run it. Okay, percent. Oh, sorry, it's percent run and grade. And we can see maybe say it's like 70, 75, enter. You see it's a grade C. So very importantly, to note, where's our code now, our grade code, that if this was true, it bypasses all of these and goes to our final statement. So we can say print done. So just to test this, what happens if we do a score bigger than 100. This will actually, let's see what happens if we do that. If we say run grade and we say once again, and we say, what about 200? It will score it as grade F, which is actually incorrect. It's that we should maybe add a check if the score is bigger, maybe bigger than bigger. If score is bigger than 100, then this is should say this is not correct. This is not a correct grade, and then we can say that, and then add else, then say um, else score. Then we can say else the other grade, which was just print D like that. So let's see if that works. All right, run it again. So 200. There we go. That one works. Right, notice that by executing Python grade of pi, you'll be able to input a score and get a grade. However, notice how there are potential bugs. Typically, we don't want to ever trust our users to input the correct information. We could improve our code as follows. We improved it by saying, by taking away the and, is what I can see. By taking away the and, it's a one difference. And allows you to chain together operators and conditions in a way quite uncommon to other programming languages. So we can chain it. So this is pretty much identical. With score, less than equal to, less than equal to. Right? So, but looks a bit more efficient. We can improve it even more. We can say the following. We can just score if it's bigger than 90. We're going to say that. But what happens if it's bigger than, so this becomes redundant. We're just hoping people would score correctly. So this would, even if to 100, it would say grade A. So maybe that's fine. Maybe that's fine. Maybe they expect that or allowed for some reason. Notice how the program is improved by asking fewer questions. This makes our program easier to read and far more maintainable in the future. You can learn more about this in the control flow in Python's website. Modulo. So in mathematics, parity refers to whether a number is either even or odd, which is really important to know. The modulo operator in programming allows one to see if two numbers divide evenly or divide having a remainder. For example, 4 modulo 2 would result in 0 because it evenly divides. However, 3 modulo 2 does not divide evenly, and we would result in a number other than 0. In a terminal window, create a new program called parity. In the text window, type your code as follows. So let's create a new Python file called parity. Apply. Let's open it up and let's copy and paste this code over here and see what it does. So we're getting input and we're checking, is the value we input divisible by 2? Is it even, or if it's odd? Notice how our user can type any number 1 or greater to see if it is odd. If it is even or odd. Let's run it and see what happens. We can say % run parity. All right. Notice that in Python, I don't need to say .py. Or in Jupyter Lab, I can just say compare the file name. This one I did just for illustration. Let's say 5, that's odd. Let's say 4, that's even. Great. Creating our own parity function. As discussed in lecture 1, you'll find it useful to create a function on your own. You can create our own function to check whether a number is even or odd. Adjust your code as follows. So now we're going to create our own function. Over here, let's go to parity code again, which is over here. And then what does this do? Well, we define a main function, which has its own code block. We check if it's even, and we print the result. And to define our own function here, which checks if it's divisible by 2, if it's a remainder. If the statement is true, return true. If false, then return false. Notice that our if statement is even works, even though there are no operator there. This is because our function returns Boolean, or true or false, back to the main function. The if statement simply evaluates whether or not is even of x is true or false. Pythonic. In the programming world, there are types of programming that are called Pythonic in nature. That is, there are ways to program that are sometimes only seen in Python programming. Consider the following revision to our program. Let's have a look. Notice that this return statement on a code is almost like a sentence in English. This is a unique way of coding only seen in Python. Return true if n modulo 2 is equal to 0, else false. This is a really nice part of Python, is that as you're coding, as you think, you can code. As you think through a problem, you can code as well. This is really a nice part of Python. We can further revise our code and make it more readable. Let's just see what else they're doing. The only change is we returning this to make it even more readable. We're just returning if returning the modulo of n modulo 2 is equal to 0. This will either return true or false. Notice that the program will evaluate what is happening within n modulo 2 equals 0 as either true or false and simply return that to the main function. Now, similar to if, elif, and else statements, match statements can be used to conditionally run code that matches certain values. Consider the following program. Let's call it maybe match. Call it match. Open, paste. Let's see what it is. Okay. Consider the program. We're getting input and we're checking if name is Harry, print Gryffindor, name Hermione, name Ron Gryffindor, name Draco Slytherin, and then print who. Notice that the first three conditional statements print the same response. We can improve this code slightly with the use of the OR statement. So this would check. So again, this is just Python improvements. It will still give the same result, but more efficient if we would just make one if statement, because we're getting the same result 3 times. Only one is different. So let's just use the example. We would say, let me just move this a little bit so we can one line. If name is Harry, or name is Hermione, or name is Ron, then say Gryffindor. Else, elif, if the name is Draco, put them in Slytherin. Notice that the number of elif statements has decreased, improving the readability of our code. Alternatively, we can use match statement to map names to houses. Consider the following code. So that you can also do this as well. So using the match built-in Python keyword, which checks if the name, if you have an input, for example, that says Harry. If you see Harry, print Gryffindor, Hermione, Gryffindor, Ron, Gryffindor, Draco, Slytherin. If nothing comes in, print who. So notice that the use of the underscore symbol in the last case, this will match with any input resulting in similar behavior as an else statement. Match statement compares the values following the match keyword with each of these values following the case keywords. In the event a match is found, the respective indented code section is executed and the program stops the matching. We can again improve the code in this way by using the OR statement. So again, just like with if else, we don't have to have so many if conditions. We can just have one and separate with the OR. If the name matches Harry, or this is symbol for or, Hermione, or Ron, say Gryffindor. If the case matches Slytherin, Draco, Slytherin, or print Slytherin, else print who. Notice that the use of a single vertical bar, much like the or word, allows us to check for multiple values in the same case statement. Summing up, you now have the power within Python to use conditional statements to ask questions and have your program take action. Accordingly, in this lecture, we discussed conditionals, if statements, control flow, or and modulo, creating your own function, Pythonic coding, and the match statement. Thank you so much. Hopefully you learned something. Until next time, goodbye.